现在只有12个。There are only 12 people here.
Yeah, maybe some get the time wrong or first day of class running late.
Okay.
It's okay.
Did you all receive the email about the Zoom link? Okay. Maybe you can turn on the camera, so say hi to Virginia.
Hello.
Hello.
Hi.
Hello. 好久不见。
So I don't know if more people are going to arrive or not, but it seems like many of you are here. So we are live streaming this on YouTube. I know in China, if you want to watch YouTube, you have to have a VPN, but it works for people outside of China. So maybe you can get a VPN to watch those videos later. If you want, I can put in the chat here the link because if we go over anything that you want to rewatch, or if you show up late, you can watch the video later too. Yeah, so I'm Virginia.
I'm Yiga Liu. Today, Virginia and I will be in charge of this workshop. And so finally, we are very happy to see you all here. And thank you very much for choosing our workshop. Today, we are going to have a brief introduction of the schedule of this workshop, what we are going to do, and later Virginia will also start our lessons on simulations for deployable structures. Before going into the course, I would like to have a self-introduction of Virginia and me. And since Virginia will have a conference in about 30 minutes, so just let her to introduce about herself first. Virginia, please.
Yeah, so I have to give another presentation in another meeting in about 20 minutes. So I'm gonna just introduce myself and then I'm going to leave and come back to give the tutorial. But I wanted to introduce you to some of my work, and you can find more of my work on my website, virginiamelnickdesigns.com. I'll put it in the chat there. But this is, so I started my PhD research in knitting 2 years ago. But prior to that, I was working in large scale installation work. And this is using spandex fabric that I would purchase at a normal fabric store. So I was doing these types of work that were large scale, immersive, and tensile structures. So this one is all suspended. You can see strings hanging these geometries in the space. And they're really meant to be kind of inhabited and experienced and immersive environment. These structures led to me wanting to do more with knitting so that I could have more control and design over the fabric, because the fabric itself here is just plain, because there's not much control over what it can do. And do I have another slide, Yuko? Yeah, here's another structure, again, tensile structure. This is still spandex fabric, which was just purchased, but here you can see it's not suspended, but there's a rigid structure inside that the fabric is stretched over, and then it is illuminated from the inside as well. So this is I think, a 2-meter tall structure, about maybe 3. I cannot remember actually, but yeah.
Next
Is there
slide.
another slide? I don't remember how many I gave you. Yeah, so then I started to research knitting, and the biggest thing I'm interested in is how to manipulate knit patterns for creating different geometries and shapes. So this is some of my very early research, but I'm also really working on simulation and designing the way that we can predict the performance of the material using Grasshopper and things like this, which I will teach you. I'm also working on simulating pattern design with neural networks. So this is using StyleGAN, and I have at home a punch card knitting machine. So these are punch cards, if you are familiar with them. They basically are binary code that controls the machine to do which patterns win. And so using these kind of neural networks to design patterns, I'm starting to generate new designs, which leads to a bit of hybrid material and opportunities for other performative aspects when you are working with 2 materials coming together, 2 colors.
I think that's all. And thank you, Virginia. Virginia is quite an experienced researcher in fabric installations, and also she's expert in knitting different patterns according to material properties. And later, she will also give us lessons on simulations about this membrane structures. And I think that's finished. You can go on to have your conference.
Yep.
Yeah,
I'm
thank
going to
you.
go prepare for my conference. I'll be back. Bye-bye.
Bye. She will be back at around 9:30 and continue our lessons on simulation. And then some brief introduction of myself. I'm I'm currently a postdoc fellow at Southeast University, and I finished my PhD in Tongji University on performance-based design method for knit composites. This is one of the structures I built during my PhD using the fabric as a format for composite structures, and also develop a workflow to generate knitting pattern for the fabrics. And after that, we also adopt this technology in practice. Here's a pavilion in Nanjing Garden Expo. And it is also a knitted fabric formwork with glass fiber reinforcement. And the pattern is designed according to stress trajectories and also some light penetration requirements. During my PhD, I also developed software that can translate 3D geometry as well as 3D patterns into knitting patterns, which is 2D pixel-based drawing, so that machine can read and automatically produce fabrics with 3D shape and customize the patterns according to performance or whatever pattern you give them. And here's a knitting pattern we generate. We also test this in a teaching program. These are chairs developed by myself as well as students in 4th grade workshop. So I just finished a very brief introduction of both of us, and then we go back to our workshop. Our workshop has 2 parts, mainly 2 parts. The first part will focus on teaching the fundamentals on techniques and technologies, the techniques and knowledge on deployable knitted structures. And the second part will focus on making. For the first part, Virginia will give you a lesson on simulation, like how this structure will deploy under its deployable process, as well as how does it reach its equilibrium. And for me, I will teach you lessons on how to generate knitting patterns given those 3D geometry, either developable surface or non-developable surface. And based on that, we will ask you to do design exploration to design these small scale physical models of deployable knitted structures. And we also prepared some physical stuff like these bending active poles and PVC pipes. And we will also let students to go into the factory to knit your own fabric. And later on, after we develop this project, we will also go deeper into the design of knitted fabric, how to generate different patterns for porosity variation, density variation, and we will also have some trials on knitting optical fibers into the fabric. The second part will be making a one-to-one scale physical model. Here's some very early rendering of this pavilion, and it is movable, so it has wheels on side, and so we will make this together. Oh, it's stuck. And also, we are very glad that we have invited 4 expert researchers in related area. Mariana Popescu from ETH, Yulia Sinka from Danish Royal Academy of Fine Arts, and Annika Klaas from Knitwear Lab, and Nicoletta Karastathy from UCL. They are both experts from architecture background as well as fashion background. They will tell us what's their latest research and share with us their experience. So, and to mention, these lectures will be held in Shanghai time at night around 9 p.m. It's all online. So it is kind of extra content to this workshop. You can also invite your friends or colleagues if they are interested into these lectures. Here are some notes. So for each day, 11 to 13, it's all in Shanghai time, will be lunchtime. And tomorrow, June 28th, offline students will go together with me to the knitting factory, and they will have a brief introduction of the machine as well. You can also bring your knitting pattern to make physical models. And the third one is that since the knitting factory is not large enough, so we are dividing our students into groups with 4 to 5 people in each group. And each time only 1 people from each group can go to the knitting factory, and the other one work with computers, but you can arrange that in turn. So maybe today you go to the factory and the other day another person go to the factory. It's up to your arrangement. And also, again, this from June 28th to July 1st at 9 p.m. Beijing time, please join the lectures. It's quite our great pleasure to have invited them, and we'd like to share their knowledge to all of you. For the expected results for this workshop, like for each group, you will need to develop videos and drawings on simulation, knitting pattern design, as well as knitting pattern generation process, because I will give you a fundamental structure for generating knitting pattern, but there will still need to be some adjustment to this program. so we can develop the Python codes together. Yeah. And also, each group are expected to make some physical models of deployable structure. So the fabric will be knitted in the factory, and we will also provide PVC poles as well as bending active elements. And online students and offline students can work together. So maybe online students can produce more on the digital model, and the offline student can work with the physical models. So and also at last we will together build a one-to-one prototype. And that's the brief introduction of this workshop. If anyone of you have any question. Okay. So then let's move to the next exciting part of our workshop. Please introduce a little bit about yourself. We are quite excited to know who you are and what you are doing. And yeah, so how to start? Just maybe the student offline can, you can turn on your cameras. Let us see you. Great. Shall we start from Siyu?
Okay, can you hear me? Hello, everybody. My name is Siyu Liu, and I come from China, but now I live in Spain. That's why everything's stuck here, and I'm trying my best to suffer from this schedule because it's like 2 o'clock in Europe. I will try to suffer from 2 o'clock to 10 o'clock every day with everybody, and it's my great pleasure. Now I'm studying my second master, as the name is Contemporary Design. It's a line focusing on interior design and in Barcelona. And I worked as architect for around 2 years ago. And now maybe I'm changing my line to become much more interior orientation. And my line is talking about the cultural combination. Now, because I want to combine Chinese culture to Mediterranean culture and making as lamp, because I find I'm super interesting about lamp design. And so now I'm working with different technology, material, and structure to make things combine each other to let each culture become much easy understanding to each other, since there's always like a bridge or gap to understand each other. Like me, when I understand Spanish, English is my bridge. So something like that, and my work is around so something like this. And later I will introduce more. And nice to meet everybody.
Yeah, nice to meet you as well. And we will try our best. If you feel too tired, maybe you can watch the live stream as well. Don't make it too hard for you. Okay, so let's move on to David.
Hello everyone, I'm currently on the offline workshop in Shanghai, and I'm studying in Tongji University. And I'm a little bit nervous because I just get started on architectural learning. I'm on the second year of my undergraduate study. So I don't have any research, just exploring different fields and learning whatever I can. So I'm glad to meet with everyone.
Also, welcome to this workshop, and hope you can find what you are interested in this workshop. Hi, Mo. What's your name? Is it Mo?
So my name's Moritz. Hi,
Sorry,
everyone.
we cannot hear you.
You cannot hear me?
Okay,
No?
yeah. Now it's okay.
Hi, everyone. My name is Moritz, which is a German name, and it's a bit difficult, so Mo is fine.
Okay.
I'm a bachelor student in fashion and technology
Great.
in Austria. Right now, I'm in Germany, and it's also 2 o'clock in the night. I will also try my best with my schedule. Yeah. I actually so the work that I'm really interested in is like using new technologies like Grasshopper and robots and 3D printers and apply them in the field of fashion. And that's why I'm here. I'm interested to see how you guys are like applying this in architecture and see what I can learn and take it back to my field.
Great. We will also try our best. May I have a question? Which city are you based in Germany?
So right now I'm in Berlin, but
Berlin.
I'm just here for an internship. So I study in a city in Austria, and I'm actually from Switzerland.
Okay, that's complicated.
Yeah, it's complicated.
Yeah, and okay. So thank you very much for the introduction. Tom.
Hello, everybody. Hello, everybody. I'm from China, Harbin, and you can call me Tom. It's a very clear name. And I got my bachelor degree from the Harbin Institute of Technology, and I got my master degree from UCL. And in 2016, my research from UCL is a catenary line structure combined by the concrete. And from 2007 to 2017, I'm in Harbin Institute of Technology for my PhD degree, and my research is large span architecture form finding using machine learning. As for the design research, I use CFD combined.
你们是什么？我下给你看。啊。
我们在上课。
上课，这里是全部腾出的，我下给你看。
对，我们申请的。
你们申请的，跟教务处申请的。
对，是的。我们正在全球直播。
我连上面。出来，我们这个上面去的。相当于下面有你肯定不是你不行的，我下面有的。
The security guard. That's it.
你们搞多少时间？
到7月4号。
不到7月4号，咱们是7月11号。7月4号，下面当时他们写的。
Sorry for the interruption. Let's move on.
Okay. Let's go. And the research from the large span architecture form finding, from the structures and the environment and fabrication. And for the structures, I make my research combined by the Chromebook 3D. And for the environment, I use the open form using combined by the machine learning. And as for the fabrication, I made 3 and 4 ice shells, the ice structure, and that's it. Okay.
Great, thank you, Tom. I think it's better to show one of the photo of your ice shell later. I think they are quite impressive.
Okay.
Using the fabric formwork. Yeah. Okay, Fred, can you give us a brief introduction of yourself?
Hi. So my name is Fred, and I currently in the offline workshop in Shanghai. So I'm studying fine art, and I just finished my first year in master degree. So I guess in this workshop, I'll just learn more and explore like more innovative stuff like with you guys. So thank you.
Thank you. May I ask, so you are now having class in Sign Art or?
No, I just finished my first year. Yeah.
Okay, okay. Yeah, welcome.
Thank you.
Liu Xing?
Hi everyone, I'm Liu Xing. I'm currently in Shanghai. Actually, I should be in the offline workshop, but I only have a desktop, so probably I'll be joining for the construction of the one-to-one prototype. I'm a designer, director, and a media artist, and currently I'm in Shanghai running my own design studio, working on some commercial projects. I generally working on various media such as architecture, installation, motion graphics, mixed realities, and 3D scan. My practice is more about combining the digital and physical together. Currently, last year I graduated from SciArc, and currently I'm a Master in Design Studies candidate at Harvard. Thank you.
Thank you. We are also looking forward to your company's work. Maybe you can share us later. And may I ask, what do you plan to use knitting or a deployable structure for your company?
Yeah, I think it's a great opportunity for me to learn the this kind of like physical fabrication techniques, and then probably they can be expressed in the digital world. Yeah, I'm quite looking forward for like that kind of pattern design and the model structures.
Okay, we will try our best to give you what you want. Okay, next Wang Chenyu.
Hey, hello everyone. I'm Chen Yuo. You can call me Ring. I currently in Shanghai now, but I study the architecture in the SAG. Sam like Fred is my classmate. I also finished my first year. For the last semester, we studied the Grasshopper to make some very interesting structures in Rhino. So for this workshop, I think I want to learn more about the Grasshopper, and it's fun to part in the physical models building. So I'm glad to be here. Thank you.
Thank you. And we also plan, we also prepared Grasshopper files for the generation of knitting codes as well as simulation process, and hope you can enjoy that later. Zhang Yiwei, old faces to me.
Hello,
Nice
my
to
name
meet
is
you
Zhang.
again.
Nice to meet you. Long time no see. Okay. I was a student in Tongji 2 years ago, and I'm now in the first year of my master program in the University of Tokyo. And my main research direction is working with my professor with developing some new patterns for rigid origami, and my work is to replace some part of the rigid part in origami to make to some flexible or shrinkable material, and I'm using Can-Do 2 simulations to effectively find the behavior of the patterns. And thank you. That's all.
Thank you, Yiwei. And we are also looking forward to integrate your research work with our workshop to see if we can do anything for that. Great. Yulin Wang, please.
Could you hear me? Yeah. And I'm Yulin Wang from Shandong University, and I will just finish my bachelor study in architecture, and I will continue my study in designer science in my school. And I will just finish my internship in robotic class in several months before this year, and I will do some big scale 3D printing with my college. And I'm very looking forward to the workshop continuing because I'm now have no so much experience with the soft materials. So I will continue my studying with you guys here. Thank you.
Thank you. Hope you can enjoy soft material in this workshop. Chen Zhishen, please.
Nice to meet you all, everyone. I'm currently a graduate student from Southeast University of Nanjing. I have just finished my graduate thesis on concrete printing and architectural design. So I'm looking forward to apply master in digital fabrication and computational design. That's why I'm choosing this workshop on deployable knitted structures. I'm very much interested in how to apply softer materials into concrete structures or deployable structures. So hope we can have a nice week afterwards.
Yeah, me too. Looking forward to a nice week. And also, I'm very impressed by your work of 3D concrete print. Hope you can just continue to show your technique in those digital making. Yeah. Okay, thank you. And so let's move to Xiao. Xiao is expert in this area.
Hello everyone. Very happy to join this group and with you. And I and Liu Yige, and we have already met for maybe 2 years ago. Yes. After my graduation from Tongji University, and I went to Tsinghua University. And my major is about formal work about concrete. And in Tongji University, I'm researching the bending active mode, and now I want to learn some more about knitting technologies because the information can be knitted into the fabric, and that is very exciting, I think. Yes, and that's all. Thank you.
Thank you, Xiao. And also I would like to mention Xiao has already developed some products based on knitting for fashion industry, and hope they sell well. And what about the rest of us, like Deng Shilong, Zhao Zhilong, Han Hongkai? Will you turn on your video, or we just... Okay, great. Don't be shy, just show your faces. Bai, Little 小超 ，LY 陈科泽，打开你们的摄像头。Okay, can you give us a brief introduction of yourself? We are very happy to hear your stories. Okay. CC Wang, can you start first?
You're still muted. We can't hear you.
Hello. Could you hear me? Okay. My Chinese name is Wang Yujiao, and I just entered my graduation ceremony from Xiamen University, and I will enter Southeast University for my master degree. And I have taken a course about in creative architecture last year, and I hope we can share a good time in this workshop.
Thank you, CC Wang. 陈科泽, can you hear me? Am I calling the right person? You can turn on your microphone. 开一下你。
Sorry. Hi everyone. I am Chen Kezhen, and I am graduated from Shandong University, and I will be studying for my master degree in Tianjin University. And recently, I am interested in the soft material and irregular space and bending active architecture. And in this workshop, I want to know how to use flexible materials to enclose a space, because my recently project is some structure that cannot provide a shelter for some activity. And besides, I want to know what is the performance of flexible materials and what is the generating logic of knitted structure. That's all. Thank you.
Thank you as well. Deng Shilong, can you give us introduction of yourself?
Hello everyone, my name is Deng Shilong from Guangzhou. I'm a post student in Guangzhou. Art. My interesting in and doing interesting research. I hope learn from every. Thank you.
Thank you. May I ask which grade are you in? I didn't catch that clear.
I'm a master student.
First year?
Yes.
Okay. So Deng is in Guangzhou, so he cannot make it here. I'm sorry to tell, but hope later we can meet offline someday. Okay, thank you.
It's okay.
Yeah.
Thank you.
Little Xiaochao.
Hey, hello everyone. My name is Yuan Chao, Chao Yuan. I come from I don't know. I come from Academy of Art and Design, Tsinghua University, Beijing. I'm the second master. Last year I joined the Zhenhao's workshop. I learned state transform. So today I glad to join the workshop. That's what. Okay.
Thank you. Very nice to meet you. And the rest people, I think they are either at exhibition fair or at their graduation ceremony. So maybe our self-introduction will stop here. And then because Virginia will come back and join us at 9:30 in Shanghai time. Sorry for the students in Europe. You have to stay a little bit more in your days. And so now we will have to group to find your partners. So we have 4 to 5 people work together as a group, and it's better to have both online students and offline students so that online students maybe work more on the simulation and digital modeling, and the offline student can go to the factory and finally produce this physical prototype. So do you have any, so can you make a group now, or I don't know. You can, or I appoint the group. It's up to you. Yeah.
Thank you.
So, Siyu will be online, right? And Mo will be online. And who else will only work online? Let me know. Zhang Yue, right? Okay.要不线下的同学先组队。So I will let offline student first group first and then combine them with online student. Is that okay? Great. Thank you. 那你们看一下怎么分组啊？你们大概比如说2到3个人一组，2个人，然后对。哎，那个陈科真，那个你们天大还有一个阿美娜，她来吗？她不来吧？啊，她说她来，她只是不能 offline， 我跟她说 online。哦，那我买。你跟她确认一下，她不来的话，那分组不考虑她。那分一下，我先看我哪边，你们俩是。但是你们这个必须得有线上的，就不来线下。我不知道现在我们线上可能有10个都是，所以最好是或者你们拆成2组，因为你们一组的话只有1个人去接那个，就是拆成2组，其实有更多的人可以去。那要不你和张红海连王和白哥，他们也应该会来吗？就是你跟白哥，也吵得吵。那杨柳也没来，他在。那要不你跟杨柳，我给你给一个清华的学姐，博士学姐。她这几天不来，但是她后面来，就是他们清华什么答辩。你们几个？你们2个？我跟 Friday。你们俩。我叫王晨。 那你们建议跟一个欧洲的学生吗？可以。你们俩人一对可以。那个，张一伟那个，就是日本的那个。你们想跟那个女生还是那个老外？都可以，都可以。好。那你们仨要跟那个老外吧？跟那个谁的？还有一些在的。那个广州美院的那个小学弟跟你对是的，他有一个小学弟比他小，他是研究生，他在做数字这一块，是家里的邓世龙。目前呢，哪里加？因为我感觉好像中国里有些人特别知道起，我总感觉还应该有一个老外。哎，这个 CC 王是谁？是王玉玲是吧？王玉娇。Okay, so I just arranged the group, so I will name it to make sure you all remember. Group 1, 袁朝潘宏凯. Group 2, 白鸽张笑. Group 3, 杨柳陈志深邓世龙. And Group 4, 王玉玲汪瑜娇陈科珍 and Mo. So Mo, it will be 你们开一下摄像头。Hi, yeah, 陈科珍 CC Wang and 还有谁？是哪一个？玉林王 CC Wang and 陈科珍 will work together with you. Yeah. 刘思雨 you will work with 葛家豪、刘星、王晨宇. Can you turn on your video and wave your hands? 刘星 and Fred Ge. Wang Chenyu. Okay, you four work together. And the last group will be Luo Ruizhe, Zhang Ruinan, Zhang Yiwei. You can wave your hands online so your group can recognize each other. Yeah, it's Tom and which one? Lori David. Yeah. Okay. So so the group will be like this currently, and maybe more students will join us. So will be sent to each group later. because some students are still busy with their ceremony and they haven't show up yet, but now we will work in this form of groups. Great, so we still have half an hour to wait for Virginia. Maybe, do you have Grasshopper already and Kangaroo too installed on your computer? So I can now send you the file of Virginia to your mailbox and you can check them.
I checked, I just installed a Rhino. So yes, there is Grasshopper, and I will write my email to receive the file.
Okay. Do you have Kangaroo too, the plugin? Okay, I can send you the link so you download them. Okay, just wait a minute. I'm sending the file. So if you have Rhino 7, I think there's no necessary to install Kangaroo 2 because it's already in. If you are Rhino 6, please following the link I send you in an email and download Kangaroo Physics, the latest version. And install it. I'm also sending you the simulation file Virginia created in the attachment. So if you have finished installing the Kangaroo 2, you can open these two files and have a look at it. So I will also show you, we have prepared some material for you like this. This is the bending active pole, and we have prepared joints like joints like this, so that it can be bent into. Can you see that clear? It can be like this. Here we prepare some joints and also some clamps. So we can add fabric to this pole. And also we have prepared these joints. So bending active elements can be like crossed, and using this how to say metal work to combine them, fix them. So just give you some clue, the material we have prepared for you. These are bending active poles, and here are also some PVC poles. It's not bending, it's straight, so it can be so it will not bend. Yeah. And another element is this one is for so it can change its length. Yeah. So this is this long, and you can change its length and to make it deployable. So these are the three rigid elements we prepared. And for the membrane, we will use Stoll machine from Germany. It is the Germany machine to knit our fabric. May I ask if any one of you have ever had knit something or have experience in knitting? Great, so you have, right?
Yeah, yes, I have.
Okay, you have it on automatic machine or?
Also automatic one and domestic and Dubier, which is the double bed knitting machine.
Oh, that's great. Can you show us some of your work so we can get knowledge of what degree are you? Because we have students from undergraduate level and to PhD level. Yeah, we have to cover every one of you.
Right now, but I didn't have sample with me.
Okay, that's okay. You can show us later. Yeah.
Yeah, okay, yeah.
I also have like experience, but only with like mechanical hand knitting machines, like the very old school ones. Nothing.
Oh,
that's it.
the hand knitting machine, right? So you already know the principle of knitting. That's enough.
Yeah.
Great. Okay. So, sorry for the waiting. We still have 20 minutes. You can. Okay. Wow, that's for weaving.
It's a tool loom, a small loom. So
yeah.
I start my practice like this way.
Great. I also start with the toy knitting machine and then move on to the automatic one. Yeah.
I also have some experience. Can I share my screen?
You can see. Yeah. Oh.
I've made a pavilion based on body movement and micro actuate. So it's just like this. The spatial form can changes according to the body movement. So let's so this is a video. It shows how the space changes and the micro actuator moves. So it is based on the bending active rods.
That's very cool. I think we just need some cloth to make it architecture.
Thank you.
Anyone has anything to show us? I think because I've seen the portfolio from all of you, I think you have a lot of amazing works.
I'll share something. Knitting related.
Great.
Just a second. There we go. Okay. This is a project where I generated a Grasshopper code that creates the knitting structure. So the code itself takes like the UV lines of a 3D object, like a NURBS object, and creates the knitting, like an easy right-left knitting structure. And then here you can see like some samples that are 3D printed. So it's actually not knit, it's like 3D printed, but the structure is a knitting structure. And then here you can see it on a mannequin, like a simple test. And the whole idea was basically to take, to program into the fabric, like more density, less density, and whatever, to create a shoe that has like a, like the knitted shoe tops, but out of a 3D printer. And the second structure is like a shock absorbing structure. And combined, you have one material, but a lot of different properties in this one shoe. And that's the result. Okay, that's it.
That's cool. Is it printed on a 2D plan and then wrapped into 3D?
No. It's like modeled in 3D. The whole like already.
Wow.
Yeah.
So, great. Yeah.
So it's also the shoe is printed with an SLS printer, and it's like printed and finished. I mean, it's an SLS printer. You have to like get all the powder out, but there's no like sewing it afterwards. It's like made in one.
Actually, I'm also having a problem currently in rendering the knits because like we can generate the knitting codes and we know exactly where each knit located on a 3D surface, but it's really hard for rendering, especially when the knits are have a larger quantity. So it is time consuming and also memory consuming to rendering all the knits. So yeah, that's also, and your work really gives some inspirations. Yeah, that's great.
Good.
Thank you. Zhang Xiao, do you have anything to show us? I know you have a lot.
Okay, and I will share my screen.
Yeah, please.
这个应该怎么样才能共享屏幕？
在下面。
在下面是吧？
绿色的那个。
共享屏幕。Okay, I see it, and I will show you. And this is my work. You can see it. It is a Mongolian art, and this is a very important, interesting work, and it is a Mongolian art, and I use some form finding ways to make it, and you can see, maybe you can see here. It is a small video, and you can see it also use kangaroo, and it is something like a tensegrity system, and some members, some membranes, some fabric, and you can see here, and then let's make it, and it will grow up, and just like a Mongolian yacht. And we also make handmade model, and we use some reinforce methods to give the fabric some force into it, and then we stick the membranes on it, and then we cut it down, and then it is something like a Mongolian yacht. And but this study stopped here, since we do not learn a lot about knitting, so we cannot give this kind of information into the knitting pattern to make it something better. So yes, so this is why I think this workshop can help me a lot, and it can make something different. And this is my work, and here is the other. You can see last time Liu Yike said that I do something on the knitting. Okay. 停止共享. And I will show you this one. This one. And you can see it. It is a product on sales and on 618 and the mid-year sales. It sell out maybe 900 products. Yes, it's a very big sales, and I need some grip and some information into basketball socks, and it sells very well in China. And it is although something about knitting, but the knitting, then I just make this model, and the knitting is in the fabric, is in the factory in Xiamen. And this is their work, but this time I want to know how to knit it out, maybe by myself, so I can control the design better. And this is also very important for me, I think. Yeah.
That's really impressive. Congratulations on your big sale. Zhang Yuwei, do you have anything to show? I think you are doing quite interesting work in material study.
Probably I need to open the random for, it may take a minute or two.
What does the background tell?
It's about the combination with the rigid origami and the flex and the shrinkable material. Okay. I will share the screen for you. Okay, here can you see all the rhino and the grasshopper part? So this is typically a prototype of the pattern that I try to apply to cooperate with my professor. And in the middle part, which you can see, there are some triangles here, which is used to represent the rigid origami, which is, you see, you can take a paper and make some crease on it, and you can fold it to a certain shape, and this is called this is origami in Japanese and also in English. And my professor's work is like creating some patterns with a whole piece of paper, and now I'm working with that. Maybe I would represent some part of this this whole piece with this shrinkable material, which is can be like heat shrinkage. And my setting for this one is that it will shrink to the like 2/3 of its initial area, and maybe you can see this simulation result. So yeah, that's probably the same as I also actually made some real models for it, and I need to find.
So it will transform from 2D to 3D.
Yes, it will automatically transform from 2D plan and to 3D shape, and it's that's the main point. And I'm kind of like applying it to like repeating the patterns in the whole piece of material, and to see what will happen if it can automatically form a special 3D shape.
Okay. Let's see if our workshop can integrate with our research.
Okay, thank you.
Can I show something?
Yeah, sure.
Yeah, I heard you talking about the rendering. I used to render the fabrics.
Uh-huh. Yeah.
Share my screen. Yeah. It's not a knitted structure, but it's like a general fabric I rendered.
Can you see it? We just see gray screen. Maybe it's large.
Can you see a picture?
No.
Okay. Wait a second. How about now?
Not yet. Maybe it's large, I guess. Oh yeah, it's rendering slowly.
Oh yeah. Okay.
Yeah.
Yeah, it's like a fabric I rendered. It's not a knitted structure, but it's like very detailed fabric with patterns.
That's great.
And also have animation.
Oh yeah, we should see that. Oh, cool. So you build up the rendering model?
Yes. It's like simply a surface, but it looks like a very realistic fabric. Yeah.
Okay, thank you. My question will be, is that your rendering is based on a model or a surface or models of each need? So can you tell me if, the location of each need?
Yeah, for that animation, it's simply a surface. But if it's a knitted structure, it has real knitted tectonics. It can also be rendered out.
Okay. May I ask you which platform you are using for the rendering?
For that one, I used Cinema 4D and Redshift.
Thank you for sharing your
you.
knowledge. I find a lot of experts in our group. I feel kind of pressured.
Ike, I have a question for my research. And now because I combine things together and now I have a question for, I don't have anything on my laptop here. It's a pattern. It's from, wait a second, I can, it's from, wait, Hunan. It's a very, very local technology with this pattern like gray. And now I found some combination with this kind of pattern, like wolf pattern. But now, so I want to make it by hand since it's like something similar but different, because the wolf pattern is like 3D and I want to make it like translucent because I want to light cross it. And now I have two material. One is like this, another one is like this, but I'm not sure. Could I try in this workshop, or later I could connect you about some technology problem?
Yeah, sure. You can contact me later because I think this workshop will mainly focus on knitting. And from your drawings, I think it's maybe more suitable for weaving. Yeah.
Okay.
The quite different technology.
Oh, okay.
That would be quite interesting.
Okay, thank you.
Thank you. So I'm just making sure, so all of you have installed Kangaroo right now. Okay. So Virginia is presenting now. Maybe, sorry for student 3 animal. Sorry for staying late. Virginia says maybe we take half an hour break and she will be back at 10. I'm sorry. Or maybe you can just have a rest and we can continue to meet tomorrow. Oh, are you drinking wine?
I'm going to take my coffee. I'm sorry.
Okay. Thank you. Thank you so much for waiting. There's some technical issues at the conference, so they are delayed, but she will be back at time and she's presenting now, and sorry for that. Maybe so now take half an hour break and we will back at 10 Shanghai time. Oh, is that okay? Or maybe if you feel tired, you can go to sleep and we can continue to contact tomorrow. Yeah.
I think for me it's fine. It's fine. I mean, I have to
That's great.
an hour, but like, if anyone wants to show some more work, I'm very interested.
Yeah. I'm also very interested. Thank you. Do you have anything to show? Maybe your 3D concrete printing. Come on. It's just for leisure time.
All right. Since I'm asked to show, since I'm asked to show something about my graduate thesis, but sorry for not related very much about the fabric things. Just a second. All right. Can you see my screen now?
Yeah, you can.
Is the architectural design thesis applying the concrete printing methods. This is my final report. Text. I will just skip the conceptual design, the architectural part, and we'll jump right into the printing part. So basically we started with the clay printing by simulating the concrete process, and we wrote the G code in Grasshopper, generating the actual parts into printing parties. So this is the printing for the clay stimulation. It has some problems, and we fixed it, fortunately. We got like a small testament with different materials and different conditions of the equipment. So we finished like little parts, little segments of the architectural parts, and hopefully we finally actually have some optimization with the inner filament, the truss-like ones, for the assembly and the construction consideration. So we go to the factory to print an actual element on the scale of 1 to 5. This is the parts of like maybe 2 square meters, and we got the filaments of I think it's about 20 millimeters width. So this is the final parts of 2. It's just a finish, not totally dried in the factory. And there are some more detailed things, like we add some fibers into the concrete materials to give it a more tolerance for the bending. And also we got to make it dry quickly as it was printed out, so it can have a good performance in the in structure and also the material. So let's just briefly try in the concrete printing and the architectural design. I'll give you a small video to show the process. Wait a second. So this is a on situ video, a short clip of the printing process, and this is the first layer. And basically, it's not that fast. You have to wait for it have to extrude constantly. I'll skip to the last few layers, and it's gonna finish like in 2 or 3 layers.
My question would be like, do you set the speed parameters or just set the toolpath?
I mean, it has a
What files did you send to the factory?
G code, but you have to import into actually the factory created a system for the concrete printing. So it can use G code for its printing, but it also can create the infill patterns automatically with its software. So yeah, you can set the printing speed, extrude parameters, everything on your own, but also it depends on the conditions of the site, maybe of the materials, of the like the moisture, the things, the different ratio of the raw materials. So it depends, and it actually has a like a machine just next to the printing side. You can modify everything right there. So it's basically like this. Just a brief introduction to it.
Thank you.
Hope you enjoy.
Talking about concrete, I want to share a very interesting company called Escofit. Here. Or maybe it's mirror. It's like ESCOFET. I will type it later. And this company is a Barcelona company. No, it's a Catalonian company. And this it's always made furniture, urban furniture for chairs. So this workbook is talking about how to make chairs. And Catalonian architects unions, they are very focusing on what this looks like finally. So they don't care about which kind of program or which kind of way you make. They just care about the physical model. So every time we have to start from physical model. Okay, let me share you some. Oh, this is very interesting. It's like a concrete chairs and wait, this and also I don't know there any digital book from issue or something. I'm not sure which page I am. Anyway, and on this very interesting chairs, please just give me a second. I think let's cooperate with Enrique Milay, is a very important Spanish architect. And this one, is somebody here?
Okay, so you are speaking, right?
I'm sorry?
Yeah, you are showing something to us, right?
Yeah, about concrete and the shape and how to make it become much more, how to say, comfortable. Because I feel like it's a different way, like, I feel like in this workshop and majority of people enjoying this workshop is about to explore I'm sorry that it's night here, the technology, the different possibility of technology, but I found it's different from an idea in Barcelona about result. It's about how could make things like extraordinary, like how to make things shiny. And I don't know how to make it, but actually the work and the quality of the city is full of this wonderful work. Also make different materials. And I just want to show the difference from that. And since now it's like a small talk time.
Yeah. So you are more like project oriented, like so you may like have an idea for a project and then polish this technique to an extreme?
Not now, but I'm trying to become very good at modeling because every time they need a model. So that's why every time I have to make some handmade model. And I feel like that's the different experience from I learning in China. Yeah, and every time a physical model and have work, and my college have wonderful modeling technology, and that's it.
I also have a question, like, do you have requirement on automation? Like, you can achieve very complicated craft or technique by hand, but do you have a requirement or stand on automation, or just you make it, then that will work? Or
yeah, I want to know it because it's another word for me, but actually here every time they teach every technology from hands, they want so every process from a physical model, so nobody could only accept a digital model. Nobody, they always want physical model, and that's why yeah, it's about material. We talk about material a lot in Barcelona.
Yeah, I think it's also a trend now, becoming a major trend in China as well, because when turning digital models into physical ones, there's need a lot of understanding of the structure as well as materials and fabrication techniques. Otherwise, it cannot be realized. Yeah.
Okay. Oh, so later I will write down this book.
Okay, that's great. And also for this workshop, I think the more important aspect is to get understanding how to work digitally with knitting, especially automatic knitting machine, because like we have a background in architecture, it's requirement for massive production and also for large scale projects. So if everything is knitted by hand, that may have some less impact on the industry. So yeah, so we will have more focus on this automated process and digital process of knitting, and as well as developing the lightweight structure, deployable structures. So this is the name of the book, right?
It's the name of the group, the company.
Okay.
I will try to find the website.
Okay, thank you.笑哥，那个白哥愿意展示一下他做的东西吗？对啊，他是服装学院的是吧？哦，可以。对对对。Hi, Bagger.
Hi.
Great. So Bagger is expert, have a background in fashion design, I think, right?
Yeah.
Yeah.
Yeah, I will introduce myself briefly. I'm first year PhD student in Tsinghua University and major in information design. But I got my master degree in Royal College of Art in London, major in fashion, women's wear, knitwear. So that's the reason why I am familiar with all the knitting machine. So I was quite interesting about this workshop is about how the architects are using knitting to build three-dimensional structures. So yeah, that's the reason why I want to join with you, and really exciting about the following things. Now I'm going to sharing some of my works. So 1 second. Oops. Can everyone hear see my?
Yes.
Sorry, I'm not familiar with Zoom. Okay, here are some of my works, but but for knitting part, just a little bit of them, because now I'm also a lecturer in Beijing Institute of Fashion Technology. So this major is based on textile design. So the works is quite a variety of all the technique crafts, not only just about knitting, but also about embroidery and printing, and also a lot of work about fabric manipulation. Yes, so here are some of them. The first project is about smoking. This is a quite handcraft and traditional skill for textile designer. We were quite familiar with it, but in this project, we want to make it more fashionable and more modern. So finally, we think we changed the material to rebuild this pattern of this skill. For me, I was quite interesting about the using this skill. We can got three-dimensional surface. So finally, we use silicon to build this to make these samples. By using silicon, we can keep the surface about traditional smoking fabric, but also we can make it more colorful and more how to say give it a more fashionable or modern look. And we also put some LED line and something new fabric, new material on it, so we can got this kind of things. And also this one is about edible fabric. In this project, we're looking at a social issue about fashion waste. You know, we were throwing clothing every year. We didn't how to say that, that's quite material consuming and very, so we think about maybe we can design some textile or design some fabric which can be eat, so they will not making bad information about our environment. So we use a lot of fruit and things like this to build a fabric which can be edible. And for this, this part is about using module and this part is about modular surface design, and we use interlock as a construction to connect each unit and then combine them to a piece of fabric. You can see it as a fabric and also can see it as a kind of surface. And so this is some of our works, and some of them can also have stretching and transforming like fabrics. So and this part is also about making this information is also from a traditional fabric which called or handcraft which called 炉锦. So this is the traditional how 炉锦 make about, is about weaving things. So in this project we make this 2D pattern to a 3D structure and using weaving to combine them together. So this is some of the final works. Yeah, and this one is my master final collection. It's already 8 years ago. Yeah. So this is about knitting, and I did a lot of knitting works on it, and I use bobbin to knit the fabric first, and then I felt them so I can do cutting things on knitting fabric. And then I also did some patterns on it, and this
is this 3D printed on the knitted fabric, or
no? It's made by silicone because I want it soft, wearable. So I didn't use 3D, but this one is 3D made it, and this accessory actually is a cooperation work with RCA students from architecture and jewelry. So I was quite interesting and about this how architecture student they do things, they use Rhino and this kind of things, and they use a totally different way than.
Do you use like for the knitted costume? Do you use Grasshopper or other software to generate knitting codes or okay?
So that's the reason why I'm here.
Yeah. I'm also very interested in how do you work? Like you have already produced marvelous piece of work without using complicated Grasshopper components. Yeah.
Yeah. We did draping things. We have a model of like human body, and we use some fabric and we put on it and we pin it so we can got a shape.
I see.
Then we knitting. Yeah. And
is
also because knitting fabric, they have very good structure and
yeah.
Yeah, so you don't need to make it exactly the shape.
Oh, I see. Yeah, it can deform.
Yeah.
Like when stretching it. Yes.
Yeah. And for this part, I need give you some details. Can you see those two different pattern?
Yeah, yeah.
Which
Quite
is quite like
Mhm.
lace, and this one is quite structure and have this kind of woven surface. But actually, they are same pattern in knitting machine, using same scales. Not scales, same pattern actually, but in different gauge. This
Oh,
one I
see.
remember is 5 gauge or 7 gauge, and this one is 1.5 gauge in the 1.5 machine.
So
So
they
I
have-
just changed the tension, so you got totally different effects.
Yeah, that's great.
That's quite interesting, yeah.
Yeah.
So I knit this lace like fabric first, then I use hair press and the bounder to how to say that, to bound them together with print, and then I using laser cut to cut a pattern mold about this floral pattern. Then I put the model on the fabric, then let the silicone on it. When the silicone becomes solid, you can got the things. Yeah, because the silicone is liquid-like, so they can go through into the fabric. So it's like stick on it.
Yeah.
Yeah.
That's great. Quite impressive by your work. Because you just all present one or two images submitting for the workshop. So we can see a lot of you are already experts, and we are also desperate to see what have you done. And maybe we can change our knowledge to each other.
Yeah. Okay.
Thank you for sharing.
And also, yeah, this one is knitted. This is like one of my favorite work because here I cut the yarn, but I did because here I use some scales to lock it, so I don't lose the yarn. But here I used like double back knitting.
Yeah.
The first layer is wool, and the second layer is monofilament. So you can got this kind of effect here. Yeah, and it will
also,
go through with your body.
Yeah.
Some parts closed and some part will like this opened.
Yeah, that's great. And I think it is one of the potential of knitting to combine very complicated variations in yarn structures. So yeah, it has a lot of variations within one machine.
Yeah. It's quite a challenge for the knitting because the yarn is totally different. One is woolly and thick, but another one is very skin and delicate. If you use this two different yarn in one machine, in one pattern, it's a challenge.
Yeah, it's difficult to knit, I think.
It's difficult. Yeah. So you did quite a lot knitting work, right?
Yeah. Actually, my work focuses on 3D knitting with pattern variations. And
3D knitting. So you use computer machine?
A computer, yeah, it's a small CMS machine with like 7.2 gauge or 14 gauge. It machine.
Oh, 14 gauge. Okay, yeah.
We're knitting like shoe uppers. Yeah, it's commonly used for that, and we use that to knit furnitures as well as structures, building structures.
Okay, so it's Shima or store?
Store.
Store. Wow.
Yeah.
I never used store before, but I use a Shima computer knitting machine.
Yeah.
But I think it's quite different to do the package things.
Yes. But we will
I also need technician to help me to do the computer things.
Yeah, sure.
Yeah.
Okay, thank you.
That's all about my works. Thank you, guys.
Thank you. Okay, it's already 10. I will ask my partner to return. 你们要上厕所是吗？不用拘谨。
Ike, I have a question.
Yes?
Since now it's a small talk time. You just mentioned that you are exploring the 3D printing of something. And now I have a question about the process. I mean, is the what's is the process for developing like a 3D printing a knitting structure? Is that firstly you have a structure and later to combine them together, or you think them together at the beginning? That is what I am interested.
So for me, the it can both work in both ways. And for me, I start from the first that I have a surface model first or a mesh model, and then I compute where each knit is located on the 3D surface, and then map them onto 3D onto the knitting pattern, a pixel-based drawing, and then this drawing can be imported into either Shimasaki's software or store software, and they produce the G code for the machine to run. I just need to define which color of this pixel represent what series of machine actions, and then it can use color arrangement function. It can automatically change my pixel drawings into the G code. I can show you some models, but I haven't prepared well. Maybe. So it's like, can you see my screen? So this is the surface. I have already baked them. I didn't show the computation process. And so these are the computing results. These are the warp lines, weft lines. So each knit will be represented by this mesh. And the size of it is equal to 1 knit. And then it will be adjusted. Sorry. So maybe you cannot see the difference. I adjusted to have this continuous knitting path. So you can see there's one line goes through from the start, like a snake, and walking through this surface and to the very end. So this path will represent the path of the yarn. How does it go through this geometry? And so from this method, I can know exactly, this is my simulation method. Like I just turn it into abstract triangle for each knit. So I know exactly which knit is located on the location of this surface. Then I can do things like running structure analysis. Oh, what's that? Maybe it's not so clear. Running structure analysis, and also, yeah, like this. And then I can distribute jacker. Let me see. According to the stress information. And here is the knitting pattern I created. Let me think. Okay, I will change another. It's an old file, so I have to find the right layer. Oh, this is another pattern, like this one, the pattern of this. So it can translate it in a 2D pattern. So like this. It doesn't show very clear. You can see the difference, color difference. Maybe they're too delicate. But these pixels will be then representing the needs of different structure. I create many patterns. They are not so clear. Okay, so change it to this is the, oh, so you can see the pattern here. And here's the rotated surface. And also I have this warp line, weft lines to calculate where each knit is located. And then map it. This is the knitting path. You see from here and all knitted to the end. And here is the knitting pattern of it. Where's my knitting pattern? So you can see it here. It's not so clear. Okay, you can, oh, sorry. So it's like here. So according to this knitting pattern, it will need geometries like that. I've also tried this surface and also walls. Like this. And the knitting pattern of it. So it's all automatically generated. And here is the 3D knitting path. So in knitting, with the most basic one can be any geometry can be knitted just using one single yarn. And this red curve, continuous curve, represent how this yarn is distributed from the start to the end. I've tried many different shapes, and currently we cannot generate knitting codes for this tubular structure here. I haven't the software for generating knitting codes for tubular structures. And oh, this is the knitting pattern of it. And maybe I'm not sure. Here's some old images. This is how I start, and this is the first ugly thing I knitted with the toy knitting machine. And the first exploration on this process of generating the knitting codes. And here are some experiments.
We cannot see the photos. We are still seeing.
Okay.
Right now.
Yeah. Okay. So I will change my screen. Wait a moment. 我的屏幕是吗？ So I will show you again my machines, and here are the first machines I used for my PhD thesis. It's a toy knitting machine, and then move to this double bed semi-automatic machine, and this one will be the machine we use for this workshop. And here are some examples that I showed you using the algorithm, but this is the very first version, so you can see a lot of arrows going on. And here's are the refined version of those geometries. Like rotating tubes. Yeah. So yeah. So the little part I will show you in the next class. I will not show you now. Thank you. Does it answer to your question?
Oh, yes, but I later have another question about, I'm sorry, I have too much question.
Yeah,
And how can you, do you remain some space for the combined with the structure? Because now I have a problem, like I made some, a handmade structure and it never be perfect like in the digital model. So it's like I have to consider, do I need to remain some to cover or combine with structure, and every time it's like, for example, here it's not very even, but I need I have a model like a semi-sphere to make my make my circle become circle, consider about the material. So which is the way you consider to remain some space for combining structure as a mistake?
First, I think the form should be an equilibrium form. Like it's a combination of bending active elements and fabric. So either from my point of view, you can have two choices: either to make it into perfect sphere structure. So you have a mold and then maybe heat it and to make it perfect round. And the other way is to just let the material itself to become the shape that it is stable. And for the fabric, because it's stretchy, and also you cannot actually make it too precise, but you can considering the tension. So when you are calculating the needs on the surface, you should calculate the tension one, not the So you stretch the fabric and to count what's its dimension and then compute. But yeah, so that will help. But fabric, if you left the fabric, newly knit fabric for one night, it may shrink. So yeah, it's maybe not as accurate as you imagine, or you can knit very dense fabric so that it is more stable in size and shape. Yeah.
Okay, thank you for everything.
Thank you for the question. Virginia, you are back. Great.
You know how the internet is such a mess? Is like presenting to a conference room and the speaker is not working, the projector is not working, the microphone, nothing is working. So it's like, oh, let's restart the meeting. Let's try again. Let's do this again. So
bye.
It's over.
Yeah, it's good. It's over. Welcome back. So I've already sent the files to all the students. I think they have all get Kangaroo 2 installed. Yeah.
All right, great.
So maybe you can show them how to play with your models.
Yeah. So let me open the file. And I will go through it and explain to you how I created the file and then how you can manipulate it and create your own models with these files. Also, I have a cat here. He's always in every meeting.
Okay.
Has to be part of things. So if you see him, I'm
Oh,
sorry.
Who?
Okay, let me share my screen. So generally when I'm working, I start by modeling, and of course there's so many ways to do things, but I start by modeling kind of the base geometry in Rhino. And actually a lot of this geometry is based on existing tensegrity forms that I find and begin to replace the strings or cables in those models with fabric or membranes. So where there normally would be like a cable, I create a surface. And I can show you how to model this one, but you should have the file already where it exists. And then from that file, you can manipulate it in multiple ways by either turning on control points and beginning to kind of move them around and change the shapes of the geometry, but also aggregating them. So creating different clusters where maybe you combine them together. And you can do both. You can aggregate and manipulate. So this is where I expect it to become very playful as you begin to design and create different structures. I'm just starting here with a 6 strut module. And of course you can take the same definition and use it for other modules that might be 4 struts or 8 struts. It really depends. And based on what I saw from the introduction, because I kind of had it playing in the background so I could do 2 things at once while we were dealing with technical issues in my other meeting. I saw a lot of you maybe already know what tensegrity models are, but basically everything is in balance as the sticks are in compression and the fabric is in tension, and it all is holding together. So for these tools that I created in using Grasshopper, the idea was to simulate some of the compression and tension of the material, as well as create deployability with them, as you can change the amount of pressure on the geometry and it will change how the forces are working. So if I open up the file, I think I have something very strange set to it. We need to set the geometry. You might have, I think I just have one surface set right now, so it's kind of floating away. But we need to set all the surfaces and all the sticks to the model. So can you guys can see the grasshopper? Okay, I just wanted to make sure. So the thing that's really important, and I probably should have spent some time maybe labeling this file for you, is that we have the surfaces coming in and the curves, because I like to start by modeling in Rhino first. You don't have to, you could actually just model it all in Rhino if you know like the points and the rotates and all those things. But I prefer this way because then I can design and then apply the forces to it. So now this little surface is floating away, but to apply the surface, we just right click, set multiple surfaces because we want to set all of the ones in this geometry. So I will select them. And you can see now all of them are activated, but we don't have all of the sticks activated yet. So then the curves, which are the sticks, we right click and set multiple curves. And then I'm just going to select the curves in this geometry here. You can also do this, it's organized by layers. So we have the surfaces and the layers there. And I think there's nothing on this layer that is in red. And then it made my computer explode because there's a lot going on. So we may need to just toggle the solver here. So we can use the button to toggle that to refresh it. And you can see it came back and it has created the geometry here as a kind of shrunken geometry. So sometimes what I do now is I'll just turn off the physical model from Rhino so that I can play with the digital one. And I have a grabber here, but actually it's not working. I don't know what I did to destroy it. It used to work, but it's not working now. But normally you can then grab it. Maybe the force is not big enough. You can see it's sort of moving when I grab it, but I maybe need to change my strength to be a little higher. I think I lost the strength. Let me add some more strength to that. Kind of moving ever so slightly when you use the grabber. Pull that up. There we go. Turn that strength up. There. Now we can like bounce it around, play with it. Fun stuff. Okay. So I'm going to go through this script step by step to show you what each of the parts are doing here and how you might start to write your own script for this, but you can also use this one that is given to apply it to geometry that you've already made in Rhino. As you can manipulate and create your own kind of modules. So first, we start with those surfaces that I input in, and I just change them to a BREP. I don't even think you need this step, but then we transform it into a mesh because Kangaroo likes to work from meshes. So from the BREP of the surfaces to the mesh, we need to create a mesh that has certain dimensions to it. So I use the settings here to set the kind of maximum and minimum properties on the mesh of how many points I want, just to add definition to it. So you can see the points that are on the mesh display. Because each of these were individual surfaces, we actually want them to join at those corner points. So then I use the mesh join battery. And most of these, I don't know where they are in the menus, and you can see I have a lot of different menus on my Grasshopper. So I usually use the double click and just type in things like mesh join to find these things because I don't know where they are. Do you prefer if I change these to the icons?
I think that's okay. Yeah, that works for me.
Okay. I actually don't know how to do that.
The first one?
It's also fine for me.
Okay. Well, so mesh joins all the meshes, so that way the corners are connected. And then we can take all of the edges of this mesh, and that's when we apply the forces and the relaxation. So we make them into springs so that the fabric responds the way that a tensile fabric would and kind of shrinks. And so we do this by taking all of the edges of the meshes that we created, and we get the length of them and multiply it or divide it by a number. So this slider here, then you can adjust how much tensile strength you want that fabric to have. So how stretchy is it, right? And this is something that a lot of times, since it is a divisible thing, when I am knitting, I will test a little sample and then sometimes actually just measure what is that percentage of stretch that my knit sample is moving, to be able to predict and feed back into the program how much I think it's going to actually stretch or respond, so that I can begin to work back and forth between the physical test samples, the digital model, and then back and feed back into creating the larger built structures. And so that goes into here, the line length, which is one of the goals to have in your Grasshopper solver. So it is then there, and then the strength here, I just have the strength like all the way up really high. But that is also a way to affect how strong those line lengths are determined. And then this one goes for the whole mesh as a load. So we want to have some gravity on this, right? Because otherwise it does kind of like float away and disappears. So this is actually just a load onto all the vertices of the mesh just to create some gravity, since we still have that. And I make this a negative strength because obviously gravity goes down as a negative strength. But you have to be careful because it might fall forever unless you add a floor. And I have somewhere in here the floor, which is you just type in floor and you can find the floor button there. And I also make that one just really big. I don't know if there's like a specific number that you need to make the floor. I just make it as big as possible. That way it doesn't just keep falling into the Z direction. So you have to make sure you have that. So we have the elasticity, the gravity, and the floor. That is all on the fabric part of our model. And then we also need to show it, because this show just makes it so that it comes out at the end of the model. Then we have the forces that are on the sticks, the struts for our model. So here in this model, I showed you in the presentation that I was working on these modules that are deployable. So I was using linear members that could expand and contract. They were actually curtain rods for hanging curtains, but I'm working on, yeah. So you have some there that you can play with expanding and contracting. So in this definition, we can take this length of the curve and play with the size of that. So this is multiplying that original length. So by moving this slider here, I'm actually changing the length of the stick, the strut length. And by making that stick smaller means that the fabric is no longer in tension. So the whole entire structure collapses. And then if you make that stick longer, it starts to pull that fabric into tension and it'll stand up on its own. So that's something that you can play with those materials in the shop, and you can do like even one or a couple of them with that, or all of the model with that strut length. So you can play with those as well. But if you keep it at all the same size, it'll just be consistent, and you can use the rigid piping for that as well. So from the stick, we also need to get the starts and ends to add a point load to those as well. So to those points, we add another gravity load because we applied the gravity load to the fabric, but we also do need to apply a gravity Z direction load to the sticks. So this also is just a negative load to add weight to the sticks, which would weigh themselves down. And then here, that's the stick length. And so all of these things, which I could label better, but we have the load on the textile, the size of the elasticity of this textile, we have the load on the sticks and the size of the sticks that you can manipulate all those with sliders, and then they all go together into the goal objects. So we just put them all in with the grabber and the floor feature so that you can begin to manipulate and play with the design. So the biggest thing is obviously, as you saw at the very beginning, I think my slider had gotten lost for the grabber because the strength was not strong enough. So if you download this file, you're going to need to add a bigger number into the strength so you can actually grab it like I do. Otherwise, it was not grabbing enough on that force. But this definition is very useful because I can then apply this same definition to any surfaces or sticks that I have in this model. So if I re-show all of my models, and you can see my models moved around because I keep pulling it around here. But if I say I don't want to model this one anymore, but I began to manipulate the length of these center pipes, and I want to know what this design will look like here, I can then apply the same definition to these surfaces. So if I right click on it, set multiple surface, and then select this one, I can apply those surfaces, and it won't work until I set multiple curves, and then I have to find my sticks in here. And then I'm going to need to toggle to refresh because it gets a little confused. And you can see now it is simulating this design here. I will turn off these because it kind of flipped around in a funny way when it did that. But now this is a whole nother design that we could fabricate, which is more asymmetrical than the perfectly round module that the previous design was. And we can do the same thing for, as you see in the definition, if I turn back on these cluster ones, like if I wanted to create a tower here, I can select all of those surfaces. So right click, set multiple surfaces, and I'm actually going to hide those for a second and select all these surfaces and watch it fall to the ground till we get our sticks. Set multiple curves. So turn the sticks on and select the sticks. And of course it freaks out until I toggle it here. And now you can see I've created a tower structure. And you can see how the gravity really pushes that tower down, because we have to understand those forces of the structure and how it will work with gravity. And this will help us understand what level of tension, how tense we need our fabric to be, and how large our sticks need to be in the design. And you can play with that as well. We can probably make our tower fall over with the grabber. So from this, what I expect is that you will start to see the possibilities for these designs, and start to design your own by manipulating which sticks and which surfaces you are applying these to, and which ones are going to be how you might aggregate them into multiple designs, and how you might begin to transform them. So like this is copying the same piece over and over, but you could stretch it and pull and change and use many different sized sticks and many different sized fabrics together and create a larger object that is aggregating different sized modules. So does everyone think that they have a grasp of how this file is set up and how you might use it to begin to play with the designs? Are there questions?
I have a question like for the aggregation.
Yeah.
Is there any rules for the aggregation? Because for this kind of tensor grid structure, when they combine with each other, so is there anything to?
So I was aggregating them just by connecting the tops and the bottoms to get like where there's kind of like a piece that matches, because it creates this kind of triangle in that shape. Okay. But that rule actually, it means that some of the sticks come together in the corner, which is okay as long as you're connecting them with the fabric. But you could also design one where the sticks are meeting in the middle of the fabric of the previous model. Yeah. Okay. So I didn't create that one, but you could definitely do that as well.
Okay. I have another question. Like, yes. Because we also prepare some bending active elements.
Yep.
So do you have?
So I didn't have time to make the models for those. Because my Grasshopper model for that was not working as well. And I'm so busy, I'm so sorry. But did I show you those photos, or the ones that I made on previously, which
maybe you should show us. And also if you have some
so these ones
yeah
use bending active members as well. So the problem is that I modeled these in Rhino, and then my Grasshopper for the bending wasn't working. So I couldn't simulate the bending the way I wanted to. So I had to make these like rigid, but they're actually bending. But this is another direction that you should consider to try to play with, because we have these kind of bendy pipes as well. And you can connect.
So maybe because you have already made some small samples, can you maybe they don't work in all the situations, just like the model you send us, maybe send us some primitive models so that they can, because some students are not familiar with this this bending active structure, so they can,
so the bending in my Grasshopper doesn't work, but the fabric works. So these are just like rigid arcs and curves that the fabric is on. But I can send you those models so you can orbit around them and see how they're constructed and create your own ideas from it. These, I think, were not as simulated as well. They were much more physical experiments rather than digital experiments, as the other models were much more back and forth between the digital, the physical within my work.
Yeah, and also from the introduction, I think there are some students in our group already did some amazing work on bending active poles, and it's also movable with robotic connection. Maybe we can discuss together and to let them explore this membrane and bending active structure simulation.
Yeah, for sure. I think when we looked at your portfolios or the samples that everyone sent, and obviously what you were showing us earlier today, many of you are very skilled and some of you are very new. So we have quite the range. And so, you know, we were very flexible with working on whichever direction you want to go. We're just setting up some tools and giving you the time and space to have some feedback and collaborate on all these ideas that many of you are already very interested in.
I have another question, like for generating the knitting pattern. So which geometry do you set as the input geometry? The one
Yeah,
that
so I then take the Grasshopper mesh and bake it, and then I use that to create the knitting pattern.
So it is the result after kangaroo completes, right? Okay.
Yeah. So that the first rhino is the setup, and then I will bake this and create the knitting pattern from this one. I think you have to pull out the parts, because if you just bake this, it's going to bake the whole entire thing with all the points and stuff. But you'll want to find which one is the surface and just take the mesh, and then this is what I would use for the pattern, not the original file. So that's why I have some like extra layers.
Okay. Does anyone have any question? So I think for this workshop, we just start from this very basic prototype, and you can design your own little things based on this Grasshopper, or if you are more interested in the bending active membrane structure, you can also add bending active elements into the structure. And then tomorrow we will make this physical model and teach you how to knit. So don't worry about if it looks simple or anything. We just start from the very basic and go through all the workflow. Is that okay for you?
Yeah, and I think my Grasshopper script for the bending active was not so successful. So if any of you have ways to develop on this and make a better Grasshopper script than I did, great. I will really appreciate seeing that.
Yeah, I believe there must be some talents.
Yeah.
Yeah. Okay, so it's almost 11, near lunchtime. Maybe I just go through with all the students and talk with their thoughts. And also you are already grouped, so you can talk with your group. Maybe you can have some